You know fields, right? So error frame consists how many fields? 2 fields. So what are they?
Error flag, error delimiter.
Thank you. Error flag and error delimiter. So delimiter will be always common. Okay. So error flag and error delimiter. So error flag consists of how many bits?
6 to 12.
6 to 12, guys. Okay. So 6 to 12. Why? Because when one error flag is being sent, there is a chance that another controller also may try to send the flag, try to send the flag. So there is a chance that minimum 6, maximum 12 bits will be coming in this flag. Okay, possibly. And delimiter?
8 bits.
8 bits, always. Okay, so always 8 bits. This may be varied. Okay, so 6 to 8 bits. So these 8 bits, delimiter bits always will be what? Which kind of bits will be? Dominant or recessive? Delimiter bits, anywhere, any number of bits will always be recessive. Okay, recessive means 0 or 1?
1.
Ones.
1.
So let's remember those things. Okay, so now moving on to the topics that we are planning to cover: overload frame, interframe spacing, physical layer overview. So let me touch upon with interframe spacing. Interframe space, sometimes referred as IFS. Okay, so interframe space is something is present between data frame to data frame, or request frame to request frame, or between data frame and request frame. Okay, so data frames, రెండు data frames ఏమైనా వెళ్తుంటే between the frame to frame. Let's say I want one controller sending one data frame. Controller 1 sent one data frame, for example. Next, controller 2 want to send another data frame after okay, another data frame after controller 1 frame. Okay, so it has to wait for some time. It has to wait for some time so that the first data frame is complete. I mean, so that sending earlier data frame is complete. So in order to ensure that in order to ensure or to guarantee that the other frame is sent, so in between there will be a gap. So that gap is fulfilled by interframe spacing. So interframe spacing అంటే ఏం లేదు, ఒక డేటా ఫ్రేమ్ పంపించాం, తర్వాత ఇంకో డేటా ఫ్రేమ్ పంపించాలి అంటే మధ్యలో కొంతసేపు వెయిట్ చేయాలి. సో దట్ వెయిటింగ్ పీరియడ్ ఈజ్ ఫుల్ఫిల్డ్ బై ఇంటర్ఫ్రేమ్ స్పేసింగ్. It can be between data frame to data frame, or data frame to error request frame, or request frame to request frame. Okay, so interframe spacing అంటే ఏం ఉండదండి, 3 recessive bits will be there. Okay, so that is only interframe spacing. Okay, so that will be interface frame somewhere, interface IFS interframe spacing. Interesting. Okay, so generally that is what it is. It is not here, but interframe spacing will be done between the two data frames, data frame or remote. Guys, is it clear? Interframe spacing, రెండు మెసేజ్ మధ్యలో you need some gap between the frame to frame so that the receiver will be ready to receive the next one. So that is your interframe spacing. Any doubts in interframe spacing? As usual, silence. Okay, at least raise your hands if you are clear.
Understood, sir.
Okay, 2 people clear, 3 people, 4, 5, 6, 7 people clear. What about others? That's Archana not there. Okay. Archana, any doubt? No. We have to be specially called. Okay. 11 people. Okay, still fine. Okay. Now, overload frame. Okay. So, any guess overload frame means what? By the name of it. Can guess roughly. What do you mean by overload frame?
Excess information or additional information.
Additional information. Thank you for the attempt. Any other excess information or additional information is one option. Whoever is answered, thank you for that attempt. Good. Any other overload frame means what?
Too much messages at a time.
Sorry.
More messages sending at a time.
Okay. More messages sending at a time. Okay. Any other? No. Yes. That's all. Okay. So excess information, additional information, more messages sending at a time. So it is indirectly correct. You can see that in that context. But the idea of defining the overload frame is, let's say you are having some controllers. They are sending something on a network. Okay. So this is the network. So CAN network will be having how many lines? 2 lines will be there.
2.
Right?
2 lines. Can hook and can low.
So just for clarity, I'm just drawing a thing. So they are connected to the network. Okay, controller A, controller B, controller C. Need not be in the same order, and it can be anything. This is only an example. Okay, so there are these many controllers. So now controller A is sending data onto the network. But when the controller A is sending data to the network, maybe controller C is busy doing some important task. Okay, it is processing the signal information. Sensor sends some data, so it is processing that information. But A cannot wait whether it is processing the information or not. It will keep on doing that thing. So at that time, C will say, hold on, do not send any more information. I am processing something on my activity. So it can tell to the A that, okay, you are sending information, wait for some time. I'm processing some other data. So it can tell like that. So that A will know that C is unable to receive the data. I have to wait for some time. So this is one way of communicating that I am busy. You wait for some time before you send some data to other people. So in that cases, whenever any one of the ECU takes control of the bus, become master, start sending data, the receivers, if they want to convey to the master or the transmitter who is sending the data that, okay, master, wait for some time, I'm processing some message. So I need some more time to receive your message. So you want to convey back that message. At that time, you can say that I am busy by sending the overload frame. So overload frame will indicate transmitter that one or more receivers, okay, are busy processing data, okay, are unable to receive the message that is sent. So, or it needs more time to process the message received. In either of this condition, the receiver will send the overload frame. then transmitter will wait for some time. Okay, so for that purpose, overload frame will be sent. Everybody clear why we send the overload frame? Overload frame ఇందాక చూసాం కదా actually. Yeah, okay. So it is generated due to two conditions. Okay, so one is if the receiver is not yet ready to receive the next frame. Okay, it received one message. The next message it is busy in to process this. Okay, you send some message, immediately after that you are sending another message. So here message is also called as frame. Okay, so both are equal in this context. Okay, so you send one message. After one message sent, the second message you are sending immediately. One message being sent, second message on the way. So then between this message to this message, one of the receiver is still processing this first frame. So that time receiver will send overload frame. I am overloaded with the first message itself. You do not send the next message. You wait for me for certain time. So that is the purpose of using the overload frame. Everybody understood? Anybody
Yes, sir.
having doubt? Pravanya, any doubt?
But after one message, we can send another message.
Sorry? Pravanya, can you repeat again?
That means ఒకసారి మెసేజ్ వెళ్ళిన తర్వాత అది బస్ ఐడిలో ఉన్న తర్వాతనే మనం మెసేజ్ సెండ్ చేస్తుంది.
కరెక్ట్
పాసిబుల్ టు సెండ్.
ఎస్, బస్ ఐడియాలో ఉన్నప్పుడే మనం ప్రాసెస్ చేస్తాం. లెట్స్ సే కంట్రోలర్ ఏ మెసేజ్ పంపించింది, ఎవ్రీబడి రిసీవ్డ్ ద మెసేజ్, ఇంటర్ఫ్రేమ్ స్పేసింగ్ వరకు వెయిట్ చేశారు, 1 2 3 ఇంటర్ఫ్రేమ్ స్పేసింగ్ కూడా వచ్చింది. Then again now D want to send let's say D want to send the data. So first message ఏదైతే వెళ్ళిందో అది ప్రాసెస్ చేసుకునే దానికి సికి కొంచెం ఎక్స్ట్రా టైం పట్టింది. సో ఆ ఎక్స్ట్రా టైం వెయిట్ చేయాలి కదా, మిగతా మెసేజ్ మళ్ళీ వచ్చేస్తే ఈ ప్రాసెస్ అయ్యే మెసేజ్ పాడైపోతుంది. సో అందుకని ఇఫ్ D is about to send when it sends the message, C immediately it will send this message, okay I am processing the first message, you please wait for me, don't send the message immediately. So our overload frame వచ్చినప్పుడు D will wait for some time, okay you have some time to process, I will wait for some time. సో అలా కన్వే చేయడానికి ఓవర్లోడ్ ఫ్రేమ్ ఉపయోగపడుతుంది అనమాట. క్లియర్ ప్రవణ్య ఆర్ ఓకే, ఎనీ అదర్ డౌట్స్ టీమ్?
And how these features are built? I mean, is it hardware enabled or software enabled?
These all are both Bharadwaj. In a hardware there will be something called device drivers which will be auto triggered based on the code written. Okay. So it is software logic that is driving the hardware bits.
Okay. That means the drivers will manipulate the registers.
Yes, drivers will tell the registers what to do. Yeah.
Okay.
Yes. So that is one. Okay. Any other doubts? No. Okay. So fine. So that is.
And one more thing. Yes. I mean, sorry for the interruption. Like we didn't got any recordings to revise. I mean, yesterday.
I'll ask the admin team to upload them because we are finding that difficulty to record and upload it. So he told he'll come back on either Microsoft Teams or Zoom things going forward.
Okay.
But until that time, these local recordings, whatever they are doing, they are coming in the size of gigabytes. So it is finding difficulty to upload it. So apologies for that delay. But going forward, maybe we'll use those teams. Maybe in April mid, I think we'll be having that. Once we have that one, it should not be a problem. So Teams you can install, or you can directly go online, or Zoom, everything web application is possible. So at that
No,
time,
because once we got the recording, so that we can revise.
yeah,
Because we're not able to recollect anything all of a
I
sudden. That's
understand that, because if people missing one session to catch
ha,
up,
ha,
for
ha,
the
ha.
second.
That's the only problem we're
Okay.
suffering. Or else we can't upload in YouTube. Making a private channel.
Either one, same thing. They have to upload it gigabytes of data. So better to go with the available applications where they
Okay.
can have the reduced size in the recording. So that should help.
Okay. Okay.
Yeah. Any other doubts? Okay. So interframe spacing will be there between the frame to frame, request frame and data frames. Okay. Overload frame will be sent by the receivers if they want to wait for some more time. If they want the transmitter to wait for some more time before sending the next message. Okay. So sometimes one transmitter keep on sending the multiple messages to process, I mean, to send one continuous long data. So in those aspects, this overload frame is much helpful. Okay, so that is one. And secondly, when two nodes, that is two ECUs which are having heavy workload, one with heavy workload, the second one with low workload, or one ECU with heavy processing speed, the second one with low processing speed. In these aspects, in order to ensure the communication between the ECUs happening reliably, this overload frame will be helpful. Okay, so that is one scenario. And also, if you see, there is another scenario. If a node detects a dominant bit during the intermission frame, okay. Okay, so here he mentioned intermission. Got it. Okay, so when the intermission frame comes, there should be 3 recessive bits, right? All recessive bits should be there between the frame to frame. Means, let's say I sent a frame. Okay, so it can be data frame or it can be remote frame. So after that, on the bus, every person should see three recessive bits. Let's say one receiver is seeing 0 in place of 1. So at that time, that receivers will keep sending that, okay, I saw 0 in the interframe space. So I'm sending the overload frame. Somebody is using this bus. Please take care. So like that, to inform that overload frame will be sent. Is it clear? When receiver intentionally want to wait for some time before transmitter sends another thing, that time you can send the overload frame. Or if any of the nodes sees a dominant bit in the interframe space instead of the recessive bit in any position, either here or here or here, anywhere, if it is seeing that dominant bit, then also overload frame will be sent. Is it clear? Overload frame will be sent in 2 cases. When receiver want to wait, when receiver wants the transmitter to hold the next message, or when it sees a dominant bit in the interframe space. So in either of the condition, overload frame will be sent. Is it clear?
So,
Okay. All right. So moving on to the next one, that is physical layer. So physical layer, so far we are talking about dominant bit, recessive bit, etc., right? So previous protocols, they were sending either 3 volts as 1 or 0 volts as 0, something like that. But in CAN, you have a different mechanism. So how they have implemented that, we will see. Okay, physical layer will be like this, and I mean, physically you will have some cable. For CAN, that is how it is. Generally, they use the DB9 connector. So DB9 connector is a one standard connector that is used in automobile industry. Even in serial communications also, you can see these connections. Okay, so it will be looking like this, in which you will use 2 cables. Okay, so that is a pair of twisted wires. So they use the twisted wires. Okay, and also they are shielded. So why shielding? That will will help us in reducing the electromagnetic interference. So when the electricity is passed through the wires, there will be a magnetic field created around it. In order to minimize that magnetic field, the cables are twisted. Okay. So one pair of shielded twisted wires are used for the CAN communication. Okay. Among these twisted wires, 2 wires, there will be twisted means like this, and you can see the white and red color twisted here. Either one of these pair can be used, or you can use the red and green twisted pair, one of these, or the white and orange. Any one of these is used for the CAN communication. You need 2 wires only. Remaining can be unused. Okay. So in this, one wire is called as CAN high signal. The other one will carry CAN low signal. Okay. That is what in the protocol, if you see, they will be mentioning like this. Okay. So either CAN high, okay, and this one will be CAN low. Or they can also call it as CAN H. Here they can call it as CAN low. Or different people will use it CAN plus, okay, and minus, things like that. Nomenclature may vary depending on persons they are using it, but 2 wires are needed. One is called, as per the protocol, is CAN high and CAN low. So that is what the protocol will say. Okay. So physical layer will physically contain the electrical signal, and bit 0, bit 1 అని మనం చెప్తున్నామంటే ఇక్కడ appear అవుతున్న voltage బట్టి ఉంటుంది. It depends on the voltage that is appearing based on these signals. Okay. So if the difference between the CAN high and the CAN low is less than 0.5 volts, then the resulting bit is considered as recessive. Okay. So the meaning ఏంటండి? If the difference between the CAN high and CAN low voltage is less than 0.5 volts. So నేను ఇప్పుడు ఇక్కడ 5 volts పెడుతున్నాను. ఇక్కడ 6 volts పెడుతున్నాను. So what will be the difference between CAN high and CAN low now? 1 volt. So will it be considered as recessive? How much it should be in order to consider it as a recessive bit? Less than 0.5 volts. So either for that case, I have to put some 4.5 to 5.5 like this. Okay. Then the difference will be within the 0.5 volts range. Agree? So that is how it will be considered. Okay. So the difference is considered. It's not about how much voltage you are transferring in here. Okay. So that is the logic he is telling. So in order to have a recessive bit being sent, how much should be the CAN high and CAN low difference? It should be less than 0.5 volts. Similarly, if the difference between the CAN high and CAN low is greater than 0.9 and less than 3.5. Okay. So greater than 0.9 and less than 3.5 volts, then only it is considered as dominant volt, the dominant bit. You guys getting this? So now let's say I'm sending 5 volts here. Here I'm sending 4.3. So what will be the difference? So the differential voltage will be 0.7. Right? Differential voltage and differential voltage I'm referring. Differential voltage. So differential voltage is 0.7. Right? So will this be considered as dominant or recessive? This particular case. I want answer from everybody. 5 volts is CAN high.
Dominant.
Is 4.
Dominant.
Now the differential is 0.7. So is it a dominant or recessive?
Recessive.
What is the rule? In order to say it is recessive, the difference should be how much? Difference should be less than 0.5 volts. Okay. If it is a recessive bit, what should be the difference? Difference should be
0.9 and less than 3.
Yeah, it should be greater than 0.9 and less than 3.5. How much is the current voltage now? 7. So 0.7 comes in recessive or dominant?
Sorry, sir, dominant.
It is neither of them, because the 0.5 volts to 0.9, there is no definition. So it can be either of them. It is undefined behavior. Okay, you should not maintain that way. They intentionally provided that gap so that it is clearly identified as a noise or other things. Okay, because there is a chance that 0.5, because of noise or some other thing, going to 0.5 to 0.55, if you don't have this gap, there is a chance that actually 0 bit is considered as 1 bit because of the noise. So they want to avoid that error, possible error in the physical layer. In order to avoid that, they have provided a gap of 0.4 volts. Okay, you understood the logic? Anything less than 0.5 volts of difference between the can high and can low is considered as recessive bit. Okay, 0.5 volts, differential of less than 0.5 volts. If the differential is greater than 0.9, okay, 0.9 to 3.5, that will be your dominant bit. Tim, are you getting it? The difference is important. Dominant or these things. So the differential voltage. Okay, you guys with me?
Yes, sir.
Yes, sir.
Check here. So this is the can high line. Okay, physically 2 wires are right. So on one wire you are putting a voltage of, for example, maybe you can take some other thing that shows can high, can low. Maybe if you put it like this, you should get some very good images from there. You can take. Okay, this is showing the voltage. No other logic. That is why I have taken this. Okay, see here. Everybody can see the picture, right? See, if you want to send a recessive bit, what you have to do, on the can high line, you put 2.5 volts. On the can low line also, you put 2.5 volts. Then what will be the voltage differential between the two lines, between the can high wire and can low
0.
wire? Means in this, okay, you are taking one pair. In this one pair, one wire will be used as can high, where you will put 2.5 volts. In the another white wire also you will put 2.5 volts. So in that particular clock, when it sees 2.5, the difference will be taken. So when the difference is taken, it is 0 volts. Because it is 0 volts, it is considered as a recessive bit. Okay, to consider it as a recessive bit is 1, right? Dominant bit, if you want to consider it as a dominant bit, so then dominant bit is read as 0, right? So dominant bit is 0. In order to consider that as a 0 bit, what should be the voltage differential? Can high will be in, let's say here it is showing 3.5, and can low how much? 1.5 volts. Then what will be the voltage difference? 3.5 minus 1.5. So the difference will be how much?
2.
So that 2 volts is falling comfortably in that range, right? So the difference between this, when he is sending, right? So when he is sending 3.5 and 1.5, so the difference is 2 volts. So 2 volts is considered as dominant or recessive? It is falling between 0.9 volts and 3.5 volts.
Dominant.
So it is considered as dominant bit. Dominant bit means 0 or 1?
0.
0.
So
0.
to send bit 0, how much volt do you have to send? 2 volts, or between 0.9 to 3.5. This is an interview question and 3.5 volts to 0.9 volts is considered dominant. Recessive is less than 0.5 volts. Generally 0 volts, but how much maximum it can go is up to maximum of 0.5 volts. ఓకే, సో 0.5 volts పంపించాలంటే మీరేం చేయాలి? క్యాన్ హైని 2.5లో పెడతారు, క్యాన్ లోని 2.5లో పెడతారు. దిస్ ఇస్ ద కామన్ వోల్టేజ్ రేంజ్ వి యూజ్ అండి ఇన్ ఆటోమోటివ్ ఇండస్ట్రీ. Okay, so in the automotive industry, this is the common voltage range you use. So how much it is really used, it will be depending on the microcontroller manufacturer, ECU manufacturer anachu, okay, or microcontroller manufacturer. So దీనికి మైక్రోకంట్రోలర్ మ్యానుఫ్యాక్చరర్ డేటా షీట్ ఓపెన్ చేసి దాంట్లో క్యాన్ హై క్యాన్ లో క్యాన్ కంట్రోలర్ అని ఉంటుందండి. దానికి సంబంధించి ఈ క్యాన్ కంట్రోలర్ హౌ మచ్ ఇట్ ఈస్ సెండింగ్ ఫర్ క్యాన్ హై అండ్ క్యాన్ లో అనేది మీరు చూస్తే దాన్ని బట్టి తెలుస్తుంది.
అంటే మ్యానుఫ్యాక్చరర్ స్పెసిఫిక్ అది.
Yes, it is manufacturer specific, but generally they will be in the range of 3.5 to 1.5 range. Okay, so మీరు మీ ప్రాజెక్ట్ ఏదైతే చెప్తారో ఆ ప్రాజెక్ట్ లో ఏ కంట్రోలర్ వాడారు అన్న దాన్ని బట్టి ఉంటుంది అనమాట. ఫర్ ఎగ్జాంపుల్ NXP M3 Cortex, ఓకే, and voltage. So then something like that.
ఇంకా అల్ట్రా లో పవర్ కూడా ఉంటాయా దీంట్లో?
Sorry,
అల్ట్రా లో పవర్, ఐ మీన్ మీరు చెప్పే వోల్టేజ్ కాకుండా ఇంకా తక్కువలో వోల్టేజ్ 0.3.
No. This CAN standard says it has to be 0.5 for this and 0.9 to 3.5. So it has to be within this range, the differential range. If it is going in ultra low power, how can this be this much range? So they have
I'm
to
asking like, do we have that facilities also?
No.
I mean, you said these are driven by these device drivers, and can we manipulate it in that way?
Yes, they can be manipulated, but they have to obey the CAN protocol rules. This is a CAN protocol. So if you are using a CAN protocol, you have to obey this range. Okay. So within this range, you can play around. Not a problem.
Okay.
But if you are going, let's say 0 to 2 volts, how can you obey this rule? So that is how it is maintained.
Okay.
So for that purpose. Still, if you can achieve within this 0.9 volts range, let's say you can play around like 0.5 to 2.5 or 0.5 to 1.2 at least.
Okay.
Then you still able to manage this range? Yes, definitely you can have it. Okay, so you have to go through that data sheet. Maybe some other time I'll dig it up and I'll show you. So this is the data sheet, and you need to at least go through one data sheet to see how it looks like at least. Okay, so there will be a CAN controller. So that CAN controller will have this in that. So there will be a physical range that will be appearing. These are the registers, which pin they are connecting. Things like that will be there. Using this Cortex LPC 178X series, within this 8X series, where your CAN channel is connected. So it is connected to port 2. So within that port 2, 134th pin, it is there. So no need in the beginning phase. I am getting it to show you the range, but I'm not seeing. Once I see, I will show you. Okay. Somebody have doubt? Yes, Purnachandra. Any doubt?
Sir, actually, డివైజెస్ అనేది ప్రిపేర్ చేసినప్పుడు అంటే డిజైన్ చేసినప్పుడు వాటిలో వోల్టేజ్ లెవెల్స్ అనేటివి లాజిక్ 1కి లాజిక్ 0కి డిఫరెంట్ వోల్టేజ్ లెవెల్స్ ఉంటాయి కదా సార్. సో లైక్ ఇప్పుడు క్లాక్ సిగ్నల్ క్యాన్ బస్లో మూవ్ అవుతుంది. సో నార్మల్గా క్లాక్ డెవలప్ చేసినప్పుడు యాజ్ ఎ పీడీ ఇంజనీర్గా ఫిజికల్ డిజైన్గా, సో అప్పుడు వోల్టేజ్ లెవెల్స్ అనేటివి సమ్ లాజిక్ 1కి 4.5 నుంచి 5 volts ఉంటే అప్పుడు లాజిక్ 1గా అంటే డిఫాల్ట్ నార్మల్గా. సో బట్ 0.6 నుంచి 1.7 వోల్టేజ్ ఉన్నప్పుడు లాజిక్ 0 కన్సిడర్ చేసుకుంటాం. సో అలా వెళ్ళినప్పుడు ఈ క్యాన్బస్ కి ఎలా సింక్ అవుతుంది అనేది డౌట్స్. క్యాన్బస్ లో డిఫరెంట్ ఉంది కదా సార్ యాక్చువల్గా మనకి లాజిక్ 0 లాజిక్
సింక్ ఈస్ ఐ విల్ టెల్ యూ. yes, so you are basically mixing two things. So for that purpose, generally this is the microcontroller. Okay, so it will have pins like this. Okay. It will have things like this. These are the pins that you will have for the microcontroller. So this microcontroller, these all pins, they are called as ports. Okay, pins are ports, whatever you name it. When I am using these two lines as a CAN protocol for the CAN protocol, so what it will do is in the CAN protocol, there will be a logic circuitry. Okay, so internally that is running. So this circuitry is designed such a way that there will be a op amp, differential amplifier, which will check the voltage between this pin and this pin. Okay, if this pin to this pin voltage is of this much, then you consider it as logic 0. I mean dominant recessive bit, that is what you want to consider, right? So that you consider it as bit 0. It is designed in this logic. Okay, so these internal logics, once it considered as 0, when you are storing that bit as 0, that is the time where the pins that you are referring, right? The chip manufacturer defining logic of logic 0 and logic 1, that will appear here. Okay, within this internal logic. But the CAN protocol that I'm talking is coming in here outside. Okay, so this chip will have 5 volt circuitry. Okay, if for internal logic, if it is taking, for example, 3.3 volts or 2 volts, whatever it is, that logic will be internally connected to here, but it has to work with CAN protocol. So whatever voltage required for the CAN protocol, all that voltages will be separately driven to these lines. Okay, so these lines will be handled by the differential amplifier in the front end when they are interfacing with the CAN protocol.
Okay, sir. Understood.
Same is the case when you are driving the LEDs also. Clear? Or any doubt? You have some other doubt other than this? Puna, is it clear or you are not clear?
Clear, clear, sir. Clear.
Yeah, clear. Okay. Got it. Any other doubts? Yes, no, no doubts. I'll move on. Okay, so that is okay. So the voltage differential it will take, guys. So in the physical layer, there will be two wires. One wire will carry CAN high signal, one wire will carry CAN low signal. So this CAN high and CAN low are connected to the CAN controller. So when the CAN controller receives, okay, you send one bit 1. So let's say this is a CAN, a microcontroller. Within this microcontroller, this is a block that will act as a CAN controller, for example. Okay, so assume that this is a CAN controller. When the microcontroller tells the CAN controller that, okay, now you have to send bit 0 to the physical wire, it will tell like that. Okay, so then this CAN controller will do, oh, now I have to send the CAN 0. That means on the CAN high, I have to apply this much voltage. On the CAN low, I have to apply this much voltage. It will consider that and it will do that job. Okay, in the physical layer, job is that one. Next, CAN 1 has come. Okay, to send the CAN 1, I have to apply this much voltage here, this much voltage here. Like that, it will apply. From these two pins, they will go to the physical lines. Okay, wherever the network is there. So on that physical lines, things will be connected. Okay, and it will be driven to the lines. So that is how it will be communicated. Okay, is it clear now?
Clear.
Okay, so I don't know how many of you are familiar with the oscilloscope. Generally, the electrical background guys, if they worked in the labs, they would have seen this image. Okay, whatever that we are beautifully seeing on the CAN high, CAN low, clock signals, CAN signals, right? So here we are seeing like this, right? CAN high, CAN low, CAN high. This is for the theoretical aspect, physically for us to consider. Okay, but in reality, because of the physical electrical properties, I cannot explain all those things now, but it will go like this. Okay, so many variations will be there. This is another reason why they will consider it as a 0.5 volts here or to manage that range between the can high and can low. Okay, so there will be certain tolerances will be there in terms of the hardware signals. Okay, so all those things really go to the real work. You can see these things in the lab like this. Okay, so this is one frame that is being sent. Initially what is the start of frame bit? Start of frame bit will be
0.
0, right? So dominant, you have to say it as a dominant. So after that, there will be a series of bits that are going 0, 1, 0, 1. They looks like this, guys. Physically on the line in the cables that you have seen, right? So in this cable, when they are physically connected in these wires, this is how they will see. We cannot even see the pulse, right? If you see, it is there in microseconds. You cannot even, for the naked eyes, you cannot see this. You have to use special tools like this oscilloscope or digital scope and all. They will be there, which can detect these things. So where it shows like this, which will be decoded by the controllers. That's why controllers have come responding it so fast. Okay, so this is one such thing. I just want to show this picture. Microseconds, you cannot even see, but controller within this microsecond. Okay, not to scare you, but I told you, right, there is a bit stuffing thing, bit timing things. I will show you later. See, okay, you saw one line here, right? Whatever you have seen. 84. Okay. Okay, so whatever you have seen here, this one particular bit, this one particular thing, right? So even this one particular bit also, okay, it is able to decode to this much. That microcontroller, it is capable of doing this many. That particular single bit, it can convert it into how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. ఇంకో 12 ముక్కలు చేయగలను అనమాట దాన్ని. టైం చెక్ చేసేసుకొని మీకు సింక్రనైజేషన్ అన్నాను కదా, రైట్? I was telling you for synchronization, it will add the sync bit or stuffed bit. I don't know how many of you remember. Let's say like this, it is going. Okay, it is coming across. For example, one controller is like this, another controller is like this. If it is going like this with some off bit, what it will do, no, when it sees the signal change on the data line, okay, start bit is coming, means dominant bit will come, so 0 will come, right? When it sees this 0, if there is, it is having some kind of offset, the controller logic is such a way that when you see the dominant bit, and if your dominant bit is not exactly matching in the edge, okay, if it is not matching within this edge, what it will do, right, it will skip some of these time quantas. They are called as time quantas. Oh, okay, నాకు ఇప్పుడు డామినెంట్ బిట్ వచ్చింది. డామినెంట్ బిట్ వచ్చినప్పుడు ఐడియల్గా నేను ఇక్కడ ఉండాలి, కానీ నేను ఇక్కడ ఉన్నాను. సో ఏం చేస్తుందంటే ఇమ్మీడియట్గా ఈ మిగిలిన అన్ని స్కిప్ చేసేసి నెక్స్ట్ ఇక్కడ నుంచి స్టార్ట్ చేస్తుంది అనమాట ఫ్రెష్గా మళ్ళీ. సో దట్ వే ద సింక్రనైజేషన్ విల్ హ్యాపెన్ విత్ ఇన్ దట్ మైక్రో సెకండ్స్. ఓకే, ఈ కాన్సెప్ట్ ఇప్పుడు మీకు అర్థం కాకపోయినా పర్లేదు. ఈ సినారియో మీకు ఎప్పుడన్నా మళ్ళీ స్ట్రైక్ అయినప్పుడు నెమ్మదిగా కాన్సెప్ట్లోకి వెళ్ళిన తర్వాత యూ కెన్ అగైన్ క్యాచ్ ఇట్ అప్. అగైన్ యూ కెన్ ఆస్క్ మీ టు ఎక్స్ప్లెయిన్. ఐ విల్ ఎక్స్ప్లెయిన్ ఇట్ ఇన్ సమ్ అదర్ వే, సమ్ అదర్ టైమ్. బట్ దట్ ఈస్ హౌ దట్ విల్ హెల్ప్ అండి. సో బికాస్ ఇట్ ఈస్ ఏబుల్ టు స్ప్లిట్ ఆల్ దోస్ థింగ్స్. ఓకే, సో that is the physical part. Okay, so see these things in this aspect. Any other topics that you want to touch upon? Otherwise I will ask some questions if you are okay to understand how much you have understood.
Sir, if possible ఆ PPT అయినా షేర్ చేస్తారా సార్?
Yes, PPT, I'll ensure I'll ask that admin to share the PPT by tomorrow, if that is okay for you guys. Tomorrow I'll ask him to share it. Okay.
Sir, your good name?
Yeah. Govardhan.
Okay, cool. Thank you.
Have any doubts? If not, I'll ask some basic questions. Understand whether you understood or not. At least, oh, okay, you can think it in that way. Oh, okay, this is how this will come across, or these things. No questions? Yes, no. Okay, so in that case, I will ask questions. Arbitration అనే పదం గుర్తుందండి? What do you mean by arbitration?
ఏదైతే ఎక్కడైతే రేస్ లో ఉంటామో అక్కడ అది ఫస్ట్ మనం తీసుకునే ప్రియారిటీ.
ఇంకోసారి చెప్పరా?
Lowest value ki highest priority ka. It will take like
Height between high priority and low priority.
Okay, I will again I will rephrase my question. Why we need arbitration in CAN? In CAN there is a word called arbitration. Why we need arbitration?
కొలిజన్ జరిగినప్పుడు
Flow controllers are sending the data.
So I am expecting some other keyword here. So I will wait for some more answers. ఇంకా అటెంప్ట్ చేయొచ్చు, చెప్పేవాళ్ళు చెప్పొచ్చు లేదా వేరే వాళ్ళు చెప్పొచ్చు, బట్ ట్రై టు అటెంప్ట్. Why arbitration is needed in CAN?
We have RTR field in arbitration.
ఓకే, మీరు అందరూ ఆన్సర్స్ చెప్తున్నారు అరౌండ్ దట్ క్వశ్చన్ బట్ నాట్ టు ద క్వశ్చన్. వై ఆర్బిట్రేషన్ నీడెడ్ ఇన్ క్యాన్?
మెసేజ్ ఐడి
CAN bus we can access only at a time, access only one node. CAN bus access only one master, other are slave because of arbitration is coming to picture. CAN bus access only one node only. If you want to transmit anything CAN bus, master it become master first.
ఓకే,
Because when two messages sending simultaneously, then CAN protocol will take the most dominant, which is more priority.
యా,
Bus allows only one, so that's why.
గుడ్. నౌ ఎవ్రీబడి అండర్స్టూడ్ ఇట్. ఐఎమ్ జస్ట్ రీఇటరేటింగ్. సి, మనకి క్యాన్ బస్ అన్నది ఒకటే ఉంటుందండి. ఓకే, సో ఈ ఒక్క బస్ మీద అందరూ మెసేజెస్ పంపించాలి. సో ఇఫ్ మోర్ దాన్ వన్ నోడ్ వాంట్ టు సెండ్ ద డేటా, మోర్ దాన్ వన్ ECU want to send the data at a time, at the same time. Remember this word. When more than one ECU want to send the data at the same time. Okay, that is the time this arbitration will come into the picture. Okay, so that is why we need arbitration. So when more than one node wants to transmit the data at a time, so then because there is only one bus, you cannot use the same bus for two people at the same time. First, the nodes will decide who will send the message first. For that purpose, they use the arbitration process. Appudu inka meer cheppochu high priority message, low priority message, dominant bit will take the high priority, etc. adantha appudu cheppochu. But first thing you have to tell is when more than one node want to send the data at the same time, because there is only one single bus, in order to decide who will own the bus, who has to use the bus first, for that purpose to decide, we use the CAN arbitration process. Clear kada kuda chepra? Okay,
Yes, sir.
yes sir.
Fine. So what is the voltage in the CAN bus allowed? How much voltage is allowed in the CAN bus?
2.5.
So how do you say that one? So how much voltage ante you have to tell. That is a trap anamata meeku estunnadi. Okay. CAN voltage you will not be said like that 2 volts or 5 volts. You have to say CAN bus operates on differential voltage. So the CAN high and CAN low difference should not be more than 3.5 volts. You can say that for the dominant stage. For the recessive, it should be less than 0.5 volts. Ila cheppali. Okay. Is it clear?
Yes, sir.
Yes, sir.
Okay. So CAN maximum speed anta? How much is the CAN? At what speed the CAN will operate? ఎందుకంటే ఇది మీకు చెప్పలేదు ఇంతవరకు.
I to 500 kbps and 250 kbps. One.
It is right. Okay. As per the CAN protocol. CAN protocol ఎవరండి కనుక్కుంది? Who invented the CAN protocol?
Bosch
Developed
company.
the protocol.
Robert Bosch.
Robert Bosch. So as per the Robert Bosch, who developed the CAN protocol, okay, standard CAN will work at maximum speed of 1 Mbps if the distance is how much? If the distance is any guesses? 1 minute.
How much time? Are you sure you play with us? Amma went to get chocolate and pineapple.
Okay.
Don't play with us. Don't close the door.
Okay. Oh, sorry, it was not in mute. Okay. Sorry, where were we?
How much distance it will be?
Oh, sorry. Yeah. So how much is the maximum speed? It's 1 Mbps. Okay. So 1 Mbps at 40 meters only. Okay. So when the CAN developed, they were developing that, keeping automotive in picture. So based on that, the speeds and the distances they have considered. So at the time, it is 1 Mbps at 40 meters. If the distance is reduced, then you can also go higher speed, but it is not guaranteed by the Bosch. Okay, Bosch, who developed the CAN protocol, they will not guarantee it. If it is at our risk. Okay, but maximum speed that CAN protocol recommends is 1 Mbps. Like someone said, generally in CAN industry, we use 250 kbps, 500 kbps as a standard rate. Okay. So they are the two standard rates that generally used. 125 also used, but currently 250, 500 kbps are used. But as per the protocol, what is the maximum baud rate for the CAN is 1 Mbps
1 Mbps.
at 40 meters. Okay, so that is what the guarantees. I hope that part is clear. So how many wires are needed in CAN for the CAN protocol to communicate?
2 twisted wires.
Automobiles and farming, agriculture.
Two twisted, shielded, twisted pair. Okay. Yeah. Yes. And also, I didn't discuss the one thing when we are talking on this thing. I think, where is it? Yeah, I have to show that entire screen. So మనకి CAN protocol కి ఇలాగ వైర్స్ ఉన్నాయి కదండి. Can you see my screen?
Yes, sir.
Yes,
So
sir.
here we are showing open wires, right? So when the open wires, if you have it, there is a issue with the signals and signals will not be transmitted properly. For that purpose, in the end, okay, so in the end,
terminated resistor 120
there
ohms.
will be a termination resistors will be provided. So that termination resistor is provided for maximum power transfer. Okay, so to have
Which resistor,
efficient
sir?
signal that is happening, it is an electrical concept. Termination resistor of 120 ohms generally we use, and practically it will be varied depending on actual physical signal, like controller how it is varied, that also will be varied. But 120 ohms is the standard resistor that we will use here. So resistor symbol is like this. So this resistor will be terminated here in this blue line, that whatever I have drawn. Instead of this blue dot, this wire will be connected between the blue green wire and red wire. Okay, this is the resistor that will be connected at the end of the open lines. So no open line should be provided. Terminating resistor should be provided. Okay, that is of 120 ohms. So why 120 ohms? As per the protocol designed by the CAN Bosch, that is what is Bosch is recommending. That is why we are using 120 ohms resistor. You can tell that to the interviewer. It's okay. But why that 120 ohms is for the maximum signal to transfer between the nodes. Okay, less noise distortions can happen at that 120 ohms. That's why it is 120 ohms resistor will be provided. Clear?
Yes, sir.
Okay. What else I can ask? Okay, how many frames in the CAN? How many CAN frames are available?
Bit error, bit stuffing, form error, CRC
Remote
error,
frame, remote
Data frame,
transmission
request frame, error frame, overload frame.
Overload frame, error frame. Okay, interframe spacing is by default and it is not considered as a frame. Interframe spacing is a standard by default is given between the data frame and request frame. That is not considered as a separate frame. Okay, and what kind of errors are possible in CAN?
Bit error, stuff error, form
Okay.
error, acknowledgement.
acknowledgement error,
Okay, bit error,
CRC
stuff error,
error,
form error, CRC
CRC error, acknowledgement error.
and error, active error and passive error.
Active error, passive error, you should not tell and type of the errors ante. So when you are explaining the error frame, then you can mention active error frame, passive error frame. Okay, but types of errors in CAN, you have to mention bit error, stuff error, what else? Form error,
Acknowledgement error, CRC error.
yes, acknowledgement error, CRC error. Good. Okay, this is all good. Why the stuff bit is provided in CAN? Why you need stuff bit?
Number of ones sequentially, then the data is receiver.
For synchronizing, sir.
Good. Both are correct, Lakshmi. Instead of telling it like more number of bits, more number of ones, you can tell like when the consecutive bits of similar polarity. You can tell that way because it can be ones or zeros. Either one can be there. So you can tell in the data when you are receiving continuously the same polarity bits, in order to ensure the proper synchronization, the opposite polarity bit will be inserted. So like that you can tell. But in single word, like someone said, for synchronization purpose. Okay. Why synchronization? That issue will come because of the hardware tolerances in the clock signal and all. There is a possibility. Okay. It is not must. There is a possibility that once in few cases, there is a chance of missing or reading one bit wrong. In order to avoid that, for ensuring the reliability, we will use the stuffed bit. Okay. What else? What else? Okay. Is CAN a synchronous protocol or asynchronous protocol?
Asynchronous protocol.
Asynchronous.
Yeah. Why CAN is considered as a asynchronous protocol? Why CAN protocol is considered as asynchronous protocol?
They don't have clock signals.
Yeah, you have to say you don't have clock signal. When you say that clock signal you don't have, then immediately the question comes. But you said you are saying 1 Mbps speed. So how you are achieving the 1 Mbps? You need a clock, right? In order to achieve the 1 Mbps signal.
Yes, sir. Because of each pulse, each bit not sync with clock pulse.
You have to say
Internally,
clock signal will be there, but there is no shared clock signal. Okay, when it is asynchronous, you have to say there is no shared clock signal between the nodes who are using the CAN protocol. Okay, clock signal alone will be considered as a wrong answer. You have to say there is no shared signal between the nodes. That is the right answer. Okay.
Okay.
Okay. Explain the data frame. Questions ilage vastayandi. Can you tell me what are the fields available in data frame, or can you explain about data frame? Then you have to start from the start of frame will be there. After that, arbitration field will be there. After that, control field, then data field, then end of frame. So you have to tell all the fields. I intentionally skipped the acknowledgement field and CRC field. So nobody is telling, but you have to practice that, and people who are using it, they will know that all these frames will be there. Okay. All right. In the acknowledgement field, in the acknowledgement slot, when the transmitter sends, which bit it will send? Will it send the recessive bit or dominant bit?
Recessive bit.
Now there are two answers. Now you people tell me which one is correct.
recessive bit, sir.
Recessive bit, sir.
You people decide, fight, and let me know. So when the transmitter sends, which bit it will send?
Acknowledgement delimiter bit. Recessive bit. That.
No. In the acknowledgement slot, not the acknowledgement delimiter. I am asking in the acknowledgement slot, transmitter has to send one bit, and one of the receiver will toggle that bit. So how many people are saying it is a dominant bit? Only 3. Okay. I'm lowering the hands. How many are saying transmitter will send the recessive bit in the acknowledgement slot, not the delimiter, acknowledgement slot? Okay. 3 and 2. Remaining 10 people, 9 people. Okay. You need answer. Okay. Everybody can see the screen. Protocol says this. Please remember this. So the node that transmits the frame transmits the acknowledgement slot as what? Recessive. And one of the receiver has to pull that recessive to dominant. Okay. Is it clear? Acknowledgement slot లో ట్రాన్స్మిటర్ పంపించేటప్పుడు రెసిసివ్ బిట్ పంపిస్తుంది. రిసీవర్ ఏదో ఒక రిసీవర్ తీసుకొని ఉంటే దెన్ దట్ విల్ బికమ్ డామినెంట్. ఓకే, ఎవ్రీబడి క్లియర్?
Yes, sir.
ఓకే, లెట్స్ సే నా దగ్గర ఈ నెట్వర్క్ ఉంది కదా. సో ఈ నెట్వర్క్ లో దేర్ ఆర్ నో రిసీవర్స్. ఓకే, ఓన్లీ ఒకటే నోడ్ ఉంది, ఓన్లీ వన్ నోడ్ అవైలబుల్. ఇట్ ఈస్ సెండింగ్ ద మెసేజ్. So is it possible to send the message or not? ఒకటే నోడ్ ఉంది అనుకోండి. Can it send it or not?
Possible.
Possible, sir.
Okay. Okay, possible. Okay. So when it is sending a message, what kind of error can occur here? How many types of errors we have? So many types of errors we have, right? In this, let's say there is only one, termination registers are there. I'm just erasing for the clarity. Let's say controller A is there. It sent a frame. Okay. You said it is possible. So now it is sending a message. So what will happen when the message is sent? Will there be any errors or not?
No, sir.
No error. Okay, then no error of question. Okay. Now, there is an acknowledgement slot and one of the receiver has to acknowledge, right? In order to ensure that one as per the bit. Acknowledgement field, who will acknowledge if there is no receiver?
The transmitter
Yes, sir.
You're getting the point? So it will throw the acknowledgement error because it will not receive the acknowledgement error. So assume that there is no acknowledgement received and controller keep on sending the data. Then what will happen?
Data loss.
Okay, data loss. What else? Because there is nobody, acknowledgement error has triggered. So when the acknowledgement error triggers, what will happen? Error frame will be sent onto the network. Correct?
So after the
So when the error frame is sent, the transmitter will count transmitter error count as 1. Correct? Agreed? So
Yes,
this
sir.
transmitter error counter will keep on increasing. So it will go from initially it will be an active error count, then it will go to passive error count, then it will go into bus off. Okay? So that is what will happen when only one node is there. Is it clear? So ఇవి మీరు సిమ్యులేట్ చేసుకోవాలి, విజువలైజ్ చేసుకోవాలి. Let's say controller is there, other controllers are also there. When the other controllers are also there, okay, something happened to this. Okay, let's say now another scenario. Controller is also there. It has a wire got cut. Is a similar scenario of exactly not having any other nodes. So if controller A disconnect అయిపోయింది అనుకోండి, it will not see that there is no other receivers లేరు అనుకుంటుంది ఇది. సో అలాగే there is a chance, as I explained to you, it will go into a bus off state. Okay, if there is a wire cut, that is how it will go into the bus off state. Challenge, I think we already crossed 20 minutes. So that is all from my side for the CAN protocol. If you have any doubts, keep posting them in the group. Once they are accumulated, I'll have a session and clarify your doubts. Okay, for recording, I'll ask the team to share the recording. PPT, at least I can ask them to share it by tomorrow. And for
Sir,
the regarding things, yeah, please
sir,
bear
I
with
have
us.
one doubt.
Yeah. Yes, Manikanta.
Sir, we have a CAN transceiver, sir. So can you please explain CAN transceiver? CAN transceiver, if it takes like TX, RX, like digital signals, it will convert to the differential voltage.
Can you repeat?
Do you know,
I'm not getting the question.
We have a microcontroller, sir. Microcontroller లో CAN కంట్రోలర్ ఉంటుంది. CAN కంట్రోలర్ మళ్ళీ CAN ట్రాన్స్సీవర్ ఉంటుంది కదా సార్ రియల్ సినారియోలో.
Yes, yes.
CAN కంట్రోలర్ అనేది లైక్ డిజిటల్ సిగ్నల్స్ పంపిస్తుంది లైక్ TX, RX ద్వారా.
Yes.
అది CAN ట్రాన్స్సీవర్ రిసీవ్ చేసుకుంటుంది. మరి CAN ట్రాన్స్సీవర్ ఏం చేస్తుంది అంటే బస్ లోకి CAN H, CAN I పంపిస్తుంది.
Yes.
సార్ అంతే కదా?
అంతే.
సార్ అది
Oh, you want to know, is it the same thing or not, or you want to have that how it is?
అయితే నాకు డౌట్ ఉంది సార్, అందుకే అడిగాను సార్, రియల్ గా అలా
Yes, yes.
జరుగుతుందో లేదో.
That is let's say this is the microcontroller. Okay, so within this microcontroller you will have one
Screen not visible.
oh sorry stop sharing, my bad. You can see the screen, right? Okay, so this is the microcontroller. Okay, this is the microcontroller. Okay, within this microcontroller you will have a CAN controller. Just for simplicity, I am putting it as a separate thing. Let's say this is a processor, this is a CAN controller. Within that microcontroller you have the processor. Okay, and then this CAN controller can be external chip also, internal to this also. Okay, both are possible, guys. Okay, so CAN controller is there. So processor will communicate with the transmitter with the controller like this. Okay, so this will be your transmitter, transmit and receive. Okay, within this CAN controller you will also have another thing called transceiver. Okay, so this transceiver, okay, this is called transceiver. Okay, this is called transceiver. Okay, so this small block. So this small block is the one actually connecting to the CAN network. Okay, here it is called CAN high, CAN low. CAN high, and this is called CAN low. Is it clear, Manikanda?
Yes sir, understood.
Yeah, so this can be another block.
Yes sir. TXRX అనేవి like digital
From
signal
here
pattern,
it will go to the
identity.
transceiver. So two chances are there. Okay, so this CAN controller part, okay, so this CAN controller part can be separately there, or it can be part of it, and transceiver will be separate. Okay, CAN controller will be part of the microcontroller and CAN transceiver will be separate chip. This scenario is also possible, or this itself, the processor will receive that CAN controller and transceiver to the other part externally. Let's say you want 3 CAN channels, then this is also possible. Okay, from here again this will also go as transmit and receive only. Okay, TX and RX will be there in these green lines that I have drawn. Okay, so these blue lines again is a transmit receive, same like this. Clear, Mani?
Yes sir, yes sir.
Yeah, these two are on these things. The one that goes onto the network is CAN high and CAN low.
Sir, I would like to know about like J1939 extended CAN, like PGN, priority, and
sorry. What is the first one?
Sir, advanced CAN గురించి ఏమైనా క్లాసులు తీసుకుంటారని అడిగాను.
Extended CAN,
ఎక్స్టెండెడ్ క్యాన్ అండ్
ఎక్స్టెండెడ్ క్యాన్ ఏం కవర్ చేయమండి, ఇది కొంచెం కాంప్లెక్స్ అవుతుంది. ఉన్న వీళ్ళకి ఫ్రేమ్ ఫార్మాట్ మారిపోతుందండి. ఇన్స్టెడ్ ఆఫ్ ఆర్టీఆర్ యూ విల్ హ్యావ్ ఎస్ఆర్ఆర్. ఓకే, సో ఆ తర్వాత దానికి అడిషనల్ గా మిగిలిన 18 బిట్స్ ఇది వస్తుంది. సో ఇలాగా కొన్ని కాంప్లెక్సిటీస్ వస్తాయి. సో దట్స్ వై వీఆర్ నాట్ కవరింగ్ ఇట్. సో ఇఫ్ యూఆర్ కవరింగ్ ఇట్, మేబీ దట్ కెన్ బి కవర్డ్ ఇన్ అడ్వాన్స్ కోర్స్. అదర్ థింగ్స్ ఇంకోటి ఏదన్నారు?
అదే సార్, J1939 TP ట్రాన్స్పోర్ట్ ప్రోటోకాల్. ఇప్పుడైతే కరెంట్ గా ఆ మెసేజ్
దేనికి వాడుతున్నారు మీరు ఇది?
ఇది కూడా క్యాన్ కమ్యూనికేషన్ సార్, అడ్వాన్స్డ్ గా కరెంట్ గా మీరు ఇచ్చే ప్రాజెక్ట్ లో టీపీ మెసేజ్ సిమ్యులేట్ చేస్తున్నాం.
ఏ మెసేజెస్?
అంటే మోర్ దెన్ 8 బైట్స్ క్యాన్ లో పంపించలేం కదా సార్. ఇప్పుడు
ఏ మెసేజెస్?
ఏదైనా కంట్రోల్ మోర్ దెన్ 8 బైట్స్ ఎట్ ఏ టైమ్ పంపించలేం కదా సార్ క్యాన్ లో ఒక పీవీఎం ద్వారా.
ఓకే, క్యాన్ అన్నది 11898 సిరీస్ అండి. Okay, this is the standard that we'll talk about. Within this you will have standard 2, standard 3, 4 like that. Okay, depending on physical layer, data link layer, etc annadi. Okay, J1939 annadi, this is the standard which exists in parallel to this 11898. Okay, so this is a ISO standard. Okay, this again you will have Europe standard and American standards. You have so many other standards. Okay, on top of that, this will also go with OBD. Okay, so within this you will. So there are so many complexities. You do not mix the standards, saying that CAN is used in here and this one, and this is not advanced, this is not old.
Okay, sir.
That is the reason I asked you where you are using it. Okay, it is not like this is advanced, this is old, things like that. Even this J1939, you have now 2 standards. Okay, J19391 and 19392. So this is OBD2, this is OBD1. So now this OBD2 is also covering up with 11898 CAN also, it will support. So don't mix all these things in this class because it is not targeted for the intermediate or advanced things. But yeah, it's good to know these topics. But these topics we are not covering here, Mani. I think you are go ahead, but people will get confused for sure. These many numbers.
Okay, sir. Okay.
I didn't even touch the 11898 for the team because first they have to acquaint with protocol and all. Later we can go on all this. Okay, all right. So that is another one. Next, any other topics? Any other questions? CAN TP we will cover, Mani. Okay, so CAN TP we will cover once the UDS covers, no? So at that time we will cover the CAN TP. So if it is only for CAN TP, we will be covering it. Okay, if no other... Sorry?
UDS classes.
UDS will also be conducted.
Okay.
Okay, if no other doubts. Yes, I think team. Thank you. Good night. CAN is finished. Any doubts, please let me know so that we can plan another session. Yeah.